Section 5.2, what is the title of it, cool kids? Growth and decay. Where's my stylus? All right.
It was right here.
He was playing with
I
stuff.
swear. Yeah, it's not right there.
Can I pick it up?
Oh, there it is. Okay, all better. Whew. Here we go. One more time. Sorry, what was the title of section 5.2?
Application and
Growth and decay. Here he comes. Growth and decay. One more time. Is the only type of growth, this growth that we're talking about, exponential? No. Any positive derivative is indicating some sort of increase or some sort of growth. We're just kind of zooming in for one section on some particular types. The nice thing, your book also does some general types as well, so you aren't just going to see exponential, but the highlight of section 5.2 is exponential growth, because it is seen so much in science, in math, in physics, in nature. So hence why we're dealing with it. We got to do quite a few examples yesterday. The yellow box is not a forever card, but this is the example that we are starting with today, and I think we only have, let me double check real fast. We only have him that we can go do homework help. Sound good? Cool. Section 5.3 is going to be pretty quick as well, hence why we have the test next Tuesday. All right, cool kids.
Wait, next Tuesday?
No, Wednesday, sorry. Close your door. If you go, this is on Tuesday. I'm forgetting.
Oh, Tuesday, awesome.
That's all? You should advocate for more. So, polonium 210. Given information. This was my summary of like a paragraph. Because remember, when we got word problems, we want to summarize mathematically, right? So long story short, we have this element, polonium 210. They said it has a half-life of 140 days. What does this little statement mean? What's a half-life of something?
Time it takes for half of it to decay into a different material.
Exactly. The time it takes for half of the substance to decay away. So only half is remaining of the polonium-210 in its polonium-210. Okay, so the half-life is 140 days. That's the time it takes for it to cut in half in 1 sense. What's the little y sub 0 mean again? Initial amount. Good. 10 milligrams. An initial value problem. Why did I put a negative KY? It's decaying. Good, good, good. If it says half, it's decaying. It's cutting in half. If it says doubling, it's growing. So, in the olden days, aka like 2 days ago, we would have had to solve this differential equation, and yesterday we actually did solve this differential equation so that we saw what it looks like, right? But, once we solved it once, we realized, hey, anytime we have a rate that is directly proportional to the amount, whether positive or negative, it'll always, always, always end up being exponential, right? So if it's exponential, we can jump to the amount equation, or the y of t equation. Remember one more time, the y of t represents the amount remaining, or the amount present, or the amount that we currently have. Amount at time t. I wasn't totally sure that we had written that at any point yesterday. Maybe we did, maybe we didn't. For those of you bugged by the mouse chilling there, so am I. Okay, here we go. So, formula for y of t, no big dealio. Plug in the initial of 10 and say we're done. Oh, wait. Who else do we want to know? We want to know k. So if we want to know k, question, what other clue do we have besides the initial amount? Not times 0, but time what? Oh, we already used the time 0 as 10, right? That's how we got this one filled in. So what is our other clue? The half-life, right? So what can we say about the half-life? How can we plug in that clue? This one's already done. We need one more clue because we need to figure out who K is. True, but that just leads us to this equation, right? So we do know decay. So we use that fact to come to this equation with y of t equals y sub naught e to the negative kt decay. But how do we use specifically a half-life of 140?
Oh, we make it 5.
make what 5?
Y to t.
Yeah, we can make y of t equal to 5. Another way of looking at it. Wait, hold on. Katrina, what were you saying? It was good. What were you saying?
Oh, I was gonna say,
Ooh, don't take half of 140.
change 140 into hours.
I think Katrina's trying to figure out what to do with 140 days, seeing that it's time and figuring out what to plug in. So her question is, should we keep it days or should we make it hours? Well, if it takes 140 days to be cut in half, I'm not sure if we want to go to hours. That'd be kind of intense of a number, right? So let's keep it days. And days is time. So we can plug that into the T spot. Yeah, Star.
Where'd you get the 5?
Oh, we're using the clue of 1/2 life. Another way of looking at it, remember from our card, 1/2 life. Was that your question too, Ella? Where the 5 came from? Okay, hold on. Okay. So I'll answer Star's question. I was thinking I might be answering both your questions at once, but I guess not. A half-life, remember from our card? That means y of t over y sub naught is equal to 1/2, true? So whatever y of t is in comparison to y sub naught, the ratio is going to be 1/2. So you could do something like, hey, I know what y sub naught is, right? So we can think of whenever we have half-life, y of t is just equal to 1/2 of the initial. So some people did this pretty quickly. They figured out that the initial was 10, and they said, oh, hey, you know what? Now I have only half as much. So they plugged in 5. Another way of looking at it is when we go to solve, we could have technically divided y of t divided by 10, and then we could have, if you notice, this is going to end up being the exact same thing. We could have divided y of t by 10 and just said, hey, I don't know exactly who you are, but whoever you are, you will reduce to be 1/2. Okay. Oh, what was your question?
Oh, that was Angela.
Oh, Angela, what was your question? Okay. How do we solve for k? Ln. Ln of 1/2, ln of e. Divide by negative 140, k is equal to negative 1 over 140. Ln of 1/2. If you guys want to be super snazzy, I wouldn't bring the 1 over 140 up as a power of 1/2. That's gross. But what you could do, let me see if you guys can follow the pre-cal math. You ready? Why is that true? What changed?
It's possible.
It's positive now, aka where did the negative go?
Oh, it went
Oh,
at
it's
the
to the
top.
negative 1. So that is.
So that is one way. Technically, guys, both of them are right. You could use either one. The 1 over 140 ln of 2 just is a little bit easier to put into your calculator. If you bring the negative 1 up as a power, remember you take the reciprocal of whatever quantity you have. But both of them are just as equally right. It's up to you. But if we're trying to find a formula, we can say dun, 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 because we got our original formula that we plugged in a 10 to. And now we know our k is equal to, oh my goodness, there's another negative in the formula. I guess we could just leave it the way it is, or we could pull the negative and make it a 1/2 again. Either way. Both ways work. Negative k, plug them in, t. Dun, dun, dun. So now you guys are going to have to interpret the next question that probably has you using this equation in some way, shape, or form. But we have practiced so far in this section what to do if they say something about doubling, what to do if they say something about half or halving or becoming half of the original. Oh, part A, remember that was our like, hey, this is a decay equation, so his rate is going to be directly proportional. And we know the initial is basically just saying what's our important information in order to keep going from. I swear, I keep seeing a hand come up. You know it's decay just because it says something about it cutting in half. Does that make sense? Okay. Alright, use it. You guys go. I'm going to freeze the screen. You're not going to see what I'm doing unless you're cheating back here. My kiddos right around me. Yes. What? Simplify it too. I don't want to see an E or an ln in the answer. You can do it. See if we can actually simplify it too. You guys ready? I'm guessing this is your first class. Okay, marks, get set, and how'd I do?
Wait, this is what? 70?
Ooh, 10 weeks. Struggle. And we did everything in days. So we have to do our dimensional analysis and say, to change weeks to days, don't we have to multiply by? There are 70 days in 10 weeks.
Why couldn't you just cancel the
Because the only way that we can legally cancel E and ln is if they are directly next to each other, meaning if all the coefficients in front have been brought within the ln itself. Oh, it's because it's 2 to the negative 1/2 power.
Oh,
So negative drops it down. Maybe I should put it like this. Start.
isn't it, one for the first one?
Uh-huh.
Isn't it just 140 negative 1, 2?
Oh, remember when we plugged into our formula, it was e to the negative k? And so we moved the
Oh.
first, does that make sense? Yeah. I know it took me a second. I'm like, wait a minute, another negative? Are you able to follow the pre-cal? We have the number in front of the ln comes up as a power. Then as soon as the e and ln are the only two people at work and everything else is put within that argument, then I can cancel out e and ln. 10 over root 2 can simplify after you rationalize to 5 root 2. The root 2 because, let me actually show that work real quick. You get 10 e to the ln of 2 to the negative 1/2 power. So negative pops it down, 1/2 puts in the square root. The negative 1/2 power, the 1/2 puts in the square root, the negative says square root of 2 in the denominator, not the numerator. So much algebra. Alright, done. Were there quite a few places to make mistakes on that one? Yeah. Just be careful. Just be careful. Learn from your mistakes. Don't be ashamed of them. Plain grace. Try to become wiser and move on. Ooh! This got exciting. How long will it take for 70% of the original sample to decay? Now, I'm going to go a little crazy. There are multiple ways of doing this. But question, why does this make sense? Yeah, if 70% decays, what percent is left? 30%. Wait a minute, but where did the 10 go? If 30% is left, that means the ratio of what we have to what we had is equal to 0.3. So I divided y sub naught to the other side, and I just said, hey, guess what? Y of t divided by y sub naught is 0.3. That's one way of doing it. The other way of doing it, if you want to see like the full progression that you could make, sometimes you really have to use this clue, that's why I'm saying it. But the full progression in this one, since you do know that you start at 10, you could have done it this way. Then you could have said, hey, what is 30% of 10? And when you divide both sides by 10, what happens? Yeah, you're just left with the 30%. That's another way of looking at it. Ooh, because 70% has decayed away, so what's the amount you have left? 30%. You see it? How long will it take for 70% to decay? If 70% has decayed, 70% is gone. Y of t says who is left. What amount do you still have? Does that make sense? 70% decay is only a 30% left. Sarah? 0.3 times 10. Oh, how much had decayed? Times 10, yeah. So you could say 0.7 times 10, or 7 has gone away and 3 is remaining. Milligrams. So now how do we solve?
Use some logic.
You could use logic, you could also use just ln. Some of you guys are like, I've done this before and I just played with the numbers in the half-life. That's one way. But since we have the math, we can use it. So we can go ahead and multiply negative 140 to the other side. We're going to have ln of 0.3 equals ln of 2 times t. So I multiply the negative 140 up. We can divide by ln of 2. Divide by ln of 2. If some of you guys want to use some pre-cal property for this, don't you dare, there isn't one. There's only a property for ln's being subtracted or ln's being added, not ln's being multiplied or divided.
Change the basic.
It is very similar to change basic, meaning we could make it log base 2 of 0.3. But then you have to plug it in your calculator. Ugh. I'm doing negative 140 times ln of 0.3. Boop, 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 boop. Divided by ln of 2. And the answer is 243.175. Ew.
Do we have to show us algebra if we're able to strategically use our calculator?
It depends on whether they say the computations that lead to your answers, if you know what I mean.
Yeah.
You can lie. Thanks, bud.
Would this be a calculator problem?
Yeah, this should be a calculator problem. And if it wasn't, you would just box it, right? And be done and say, who cares? What do we label it with? Time is measured in
Days.
days. Done, you're done. Hey, guess what? That's it. Let me zoom back in for those of you that were still writing. We're going to go look at homework help. So if I were you, I would keep your notes open because we're going to look at the sections where your homework problems are coming from because they might not be as hard as a whole compilation of word problems. The book has split it up into skills. Building up to word problems, not starting at word problems, building up to them. Okay, a couple more seconds. Couple more seconds. So we can do homework help. Okay. The sad thing is I can't exactly easily copy and paste from one into the other. So we're going to have to kind of go back and forth. It's going to be a little bit annoying, but you know what? We'll try. Is it your class we were talking about cursive no longer being taught in elementary school? So sad. Private schools might still be teaching it. Public schools, it's out of the curriculum. But the sad thing is, like, and the whole generation won't be able to read cursive unless they're artsy and they just learn on their own. And signatures is going to be like, my name is Tim. And then you're like, what? I don't, you look like you're 2 years old. Right? That's what I thought. Like, what are doctors gonna do? Just like, I don't know, 10, right? I just made up a name. Okay, so.
It's Dr. Tim, actually.
It's Dr. Most of them are. Got the next doctor. Okay, so
I'm really bad at this.
let's go check out what is going on in your homework.
It's like
I learned it in
it's like
third
this
grade.
new print.
I
And
forgot.
my handwriting.
Oh, the hand.
Another cousin.
On the side, so we'll go and you will stay. Question. Section 5.2. I had to get the hand in order to move the page. And then, anyway.
Another country that I can learn cursive.
Huh?
Like the Salvador, then you can learn cursive. And then you have to write it on the.
Oh, weird. That's cool. Learning cursive first, and then printing it. Learning Spanish. Wouldn't be that much different though? But it has the accents and the NAs and stuff.
I feel like it'd make me uncomfortable.
Because you're not used to seeing it. Yeah, that's true. Star's gonna, what is that? Alright, so, solve the differential equation. I wish I was going to the community.
Oh, okay.
I wish I was.
I wish I was. I want both.
They're both gonna be good. Yours is gonna be good too. I'll see you together and hear your stories.
Definitely.
Hey kiddos, on the first section of homework, my question to you is, now hold on. If I give you a pink one, what can you do?
Look up how to solve it on
Go watch
CalcAB.
someone solve it maybe a different way than I do. But it is an option. However, listen. What if I was to give you, for instance, over here in this section, if I was to give you number 20, what could you do if you were stuck? Look at 19 and then try to follow the pattern for 20. But question. Hopefully, we're able to, not question, comment, hopefully we're able to cover some stuff right now, my way, which I think is a simpler way. Okay, first of all, in numbers 1 through 10, question, what are they asking you to do? It's like those kids' books where it's like, what does that mean to solve the differential equation?
Solve for y.
Derived, not derived,
Integrate.
anti-derived. But the first step you must always do is move who to the other side in 1 through 4?
Yes.
Okay, move dx to the other side, and any pieces that contain a y, better go to the other side. Now number 4 is interesting, we're going to look at him in just a second. But first of all, what do we do on 5 through 10 when we have little y primes chilling? Good! Change the y prime to dy dx. So in number 10, dy dx, what do we got to do before we multiply dx to the other side? Move him over there first, then multiply the dy dx. Sorry, no, the dy stays. Multiply the dx. Let's just look at, let's look at number 4. Did I give you number 10? Brandon, did you write them down?
Yeah, I did. You didn't give us 10.
Ah, sad day. Okay, so let's look at 4 and 10. We're not going to solve the whole thing, though. Okay, number 4. Write down number 4 and number 10. I'm just going to give you a hint as to how to start, because this is where it might get a little tricky.
You said you did questions and
I'm not doing questions. I'm doing similar. I'm just giving hints as to how to start, because they can both be tricky in their own ways. And the other ones you have examples like. Okay, kiddos, so for 4 and 10, we already talked about for number 4. Multiplying dx to the other side first, right? Cool. So multiplying dx to the other side. Question. Should I put parentheses anywhere? Oh, please. Come on, help,
Yes.
help.
Yeah,
help.
around the
Where?
whole thing, then divide it over, then you should know.
And when I multiply dx to the other side, he's multiplied by everybody on the other side. So as soon as you see that, the y does not belong, but who is he a part of? The whole 6 minus y. So can I leave the 6 on the right side and move the y?
No.
No. The only way to keep going is
divide by.
divide by 6 minus y. And all I have left over here is 1 dx. Sad day.
Oh, that's what. Okay.
How on earth are we supposed to solve?
You're going to. It'd be easier if you put dy times 1 over 6 minus 1.
If you don't like the way it's written, Brandon's trying to help us out just a little bit and say, you know what, you can think of it as 1 over 6 minus y dy. But still, question, kiddos. Hey, that's x plus c. I know him. But still, on the left-hand side, what do I have to use?
U.
u sub. Moving the negative to the other side to end up with negative integral 1 over u du. Now you should know how to go from here. I've tried to address all of the common mistakes for this problem. But do we see what I did and why I did it? When we multiplied the dx, this was tied together. So when we had to get rid of the y, we had to get rid of the entire y expression. So we had to divide that whole thing to the other side. We looked at them and said, uh-oh, hopefully he's a u sub, and the answer is yes, u sub is very appropriate. The only way to solve, to be honest. Ryan, did I answer your question? You were thinking something. Never mind. You're like, can't we?
Oh, I think it's negative pick by positive.
Oh, got it. Like factor out a negative, kind of.
And then it would be negative x on the right. And then positive.
That works. Still plus c though, right? Because a negative times c is still. Okay, question number 10. We already talked about, hey, why don't you just make y prime dy dx? It helps us see things a little bit better, right? That is way too thick. I forgot I changed the thickness. Now I'm back. Okay, dy dx. But the problem is we have this little xy dude. And right now, if I multiply dx on the other side, I'm going to run into a little bit of issues. So when we were talking about it a second ago, what did you guys say to do first before moving dx? Yeah, subtract the xy. Let's get dy dx by itself. Hopefully you guys learned your algebra well back in the day. Are these two terms alike? Can we combine them? And the answer is no. So we have dy dx is equal to 100x minus xy. Okay, what if we multiply dx by both sides? dy equals 100x minus xy all times. Hopefully you're getting those parentheses in. Oh, guys, how do I move the y? Faster. If I divide right now, I'm going to divide him by y and him by y. That y will leave, but the other y will stay. I'm in just as much trouble as I was to begin with. So instead, Lauren's like, hey, there's a common x. Why don't you factor him out? How does that change the game and make things possible again? You can divide by the expression with the y that no longer has the x's, right? And once again, I chose tricky ones. But now we can say 1 over 100 minus y times dy. Hopefully you guys see we're using u sub again. Equals the integral of x dx. At which point I will say, now I can say adopt and adopt and adopt. Once again, I tried to show you this common error, not error, but confusion. They're like, add. No, don't add. He's stuck within the dx expression to try to get an expression with just y's and numbers separated from the x or x terms. Yeah. Let's go check out the directions again. I think the directions were just to solve the differential equation, which means if they don't give us any clues, are we solving for the general with the c or the particular solving for the c? General. They didn't give us any clues, right? No clues. Technically, you should solve for y alone, just because think AP practice, they say solve for y equals f of x.
There's one more with like a y squared and then ux. I said the y you get like plus or minus square root, but on the calculator answer they just leave y squared.
The plus or minus square root is good. The reason I left the y squared was probably just for the simplicity of the stating. But I'm guessing the directions probably just said solve and not solve for y. So remember, we're solving for y just in preparation for the kiddos, on 11 and 12, we're not going to go through and totally do one, but what are you trying to do? Write and solve the differential equation that models the verbal statement. Oh, hey. They're not telling us exponential growth, but they're telling us something similar with like inverse proportion, and if they don't say inverse, it must be directly proportional to. Whenever they say rate of change of, question, what are they talking about? A derivative. Now if they say of q, q is our new y. So instead of saying dy dt, we're going to say dq dt for number 11. Or for number 12, we're going to say dp dt. Is means equals, inversely proportional. Is that k times or k over? K over. And who is it inversely proportional to? T squared for number 11. Number 12 is proportional, not k over, k times. And k times who? 25 minus t. Guys, make sure that you are, in doing these problems, when you say k times or k over, k times especially, make sure you're including your parentheses. It makes a huge difference. Then it says solve by maybe multiplying to the other side, getting the variables where it needs to be. Huh? Yeah, k is a constant, so inversely proportional to, we have a constant of proportionality, k. K over t squared. Number 12, proportionality again. We use the constant k. K times, parenthesis, 25 minus t. Oh my goodness, a random slope field, just cuz? Just cuz.
Question.
Huh.
Do we have to copy this graphs? Because I don't.
You don't necessarily have to copy the whole slope field, but what are you asked to do? Are you asked to give any answer that has a graph?
Yep.
Sketch to approximate. So I want an XY axis with your sketch. Does that make sense? We don't have to do all the baby tangents. Ooh, Ryan Murphy's amazing and printed it out. Because your book says that mathgraphs.com has a slope field for you.
It's too lazy to comprehend.
So if you guys want to, you can also print it out and then just put your solution on. Go team. It says also to use integration and use the clue. Question, as soon as they give you a clue, is it going to be a general solution with the C or a particular solution with the C solved for? Yeah, solve for that C. Okay, what's going on in numbers 19 and 20? Yeah, I got to actually take what they told me and then solve it. So, for instance, number 19, you can look at a video anyways. Let's talk about him just for a second. On number 19, when it says the rate of change of n. Who am I talking about? dn dt, right? Because n is my new y. And when it says is proportional to, is it k times or k over? K times who? K times n. Doesn't this look like y prime is k times y? Or dy dt is k times y? The cool thing is, maybe you guys can see, hey, that's just exponential growth, so maybe you can jump ahead and say n of t is equal to, instead of y sub naught, it's going to be n sub naught e to the, can you guys tell if it's growth or decay? How do you know it's growth? The amount goes up, good. The amount goes up. So we can go ahead and maybe use some of the information that they've given us in order to find the k, find the n sub naught, solve, plug in chunk, right? So if you guys notice, in homework, they are slowly building to the word problems, meaning I think I only gave you like one complete word problem question, like one hardcore A, B, C, D sort of type. The rest of them, you're using clues for stuff. We still have a couple minutes, and I actually want us to especially get to the graphs right below to get my little hand after getting rid of my colory thing. Yeah.
Would n sub naught be 125?
N sub naught would be 250 because at time equals 0. Yeah. Question. What do we do for number 23? Yeah, number 23. I'm going to actually draw a graph of him. Hey, we're not done yet. Come on. That's awesome. I'm so proud. You're going back now? Close the end. 23. Try not to discriminate. So read the directions. Come on, cool kids. Oh, the directions aren't showing. Awkward. They tell us all of these graphs are exponential. How come? Swoop, there it is. Okay, so exponentials are swoops, right? All of them are swoops. Some of them are positive swoops, like normal exponentials. Some of them are steep. Some of them are like shallow, if I can put it that way. Some of them have been horizontally flipped. They're decay equations. In number 23, they give us two clues, right? Okay. What's one clue? Okay, never mind. I'll look up 1, 5. And then the other clue is 5, 2. Okay, so question. How do we make, I don't want the frozy button. How do we make an equation just given that information? If they tell us, by the way, it should fit the exponential growth equation, y equals, they say a c instead of an y sub naught. Wait, it's a decay equation, right? Oh, why can't we plug in y sub naught? I don't know y sub naught. All right, stinks. So kiddos, what do we do when we have 2 clues and we have 2 unknowns we want to solve for?
Put one on top.
Yeah, basically it's a system of equations. We could put one on top of each other, but what does that actually mean? Plug in for each.
Yes.
And then once you plug in for each, use system of equations to solve. And Brian's clue is you could divide each equation by itself and keep going that way. Bye guys! For those of you that are interested, check out the video online. I'll show you how.
Thanks for the cookies again.
Jason.
Yeah, it's on Eastern Green at Holy Song at 10.
I don't want to basically the homework.
Wait, Holy Song at 10?
But it's only because of understanding. So yeah, because of understanding the subject. Good man.
It's a lot of like reading and interpreting.
Yeah, but it's fun.
I like that.
Or you just don't like it.
I don't know.
Filled
I
in.
like it. But like it being slanted the other way would look weird because it would be slanted towards the A, and then that would be the only thing that's slanted in the picture. See, that gives it a little bit of a like different, like kind of balance.
Oh, this one does, like where it's barely slanted? Oh, this one. So maybe leave it slanted this way.
I remember my first time walking. I said I remember my first time walking.
Oh. Karen, say something nice before she leaves.
I love you, boo.
We're salty this morning.
Oh no, someone stole someone's
Bye.
food, so I can't set that. I guess I can't name it. When you did on the first one.